Question 11. Express each using absolute value notation. All three of them are very tricky. The first one is x is greater than equal to minus 10 and less than equal to 6. Part B is x is less than 0 or x is greater than 10. And part C is x belongs to real numbers. Okay, let me start with part C this time. X belongs to real number means what? Means that this is our number line, right? And on a number line, all values of x are our solution, right? So we have all the values as our solution. Is it okay? Now for that, you can write absolute functions in many different ways, but you can use the property that absolute function is always positive, right? Since absolute function is always positive, it is always greater than a negative value. Is it okay? So we can write this as greater than equal to minus 1. Equal to was not required because it is never equal to, right? So I should have actually written as absolute x is greater than any negative value, maybe negative 5 or anything like that, right? So, or I could have written answer as absolute x is greater than equal to 0, right? This is also a valid thing because absolute x is always greater than equal to 0, correct? So those are some of the possible answers, correct? But as you can see, the basic idea is that absolute x is always non-negative. Therefore, it is always greater than the negative values, correct? If I say that x belongs, there is no solution, or if I say the solution is null set, right? Let me add part D to it, where our domain, where the solution is a null set. You understand null set? Null set is no solution. Okay, no solution. Then the answer would be absolute x is less than minus value, any minus value, correct? Because absolute x will always be positive and will never be less than a negative value, correct? So this does not have any solution, correct? So here on a number line, you will just have a number line like this, but no solution. Do you understand? That is how it could be, right? Now, let's get back to question A. In question A, we are saying that on a number line, our value of x is between minus 10, let's say this is minus 10 for us, and let us say this is 6 for us, right? Including, so we include it and we say it is between minus 10 and 6. Correct? As by definition, when we are looking at an absolute function, then we are looking for kind of a center value, and we say we are so much distance away from both the ends, and both the ends should be same distance away. So the idea here is to find a midpoint always. So whenever you have a function like this, find a midpoint. So we say midpoint is, you can add them, divide by 2. So it's a minus 10 plus 6 divided by 2, right? And we get minus 4 divided by 2, which is minus 2. So we get a midpoint here, which is at minus 2. So let us say that our midpoint is here, and this point is at minus 2. Correct? Now, second part is, we have to see how far is this midpoint from the ends. That is, how much is this distance? And how much is this distance? Both are equal because this is a midpoint, right? Both are equal, correct? But how much is it? So if you do minus 10 minus 2, what do you get? Minus 10 minus 2, you get 8, absolute value, right? So you get a distance of 8, absolute value. Distance is always scalar, right? 6 minus minus 2 will also give us 8, correct? So from this center, you are interested in values which are 8 units away on either sides. Do you understand? And that gives us definition of absolute x. And then we say, well, our absolute x when shifted 2 units to left, that means x plus 2. So we shifted our absolute function to left. It is not center of absolute function, or the vertex of absolute function is not at 0. It is at minus 2, right? Then it should be less than equal to 8 units from here. Do you understand? That is what we're trying to say here. So basically, this is our absolute function, and what we did was we shifted our absolute function 2 units, correct, to left, right? And then if we have a horizontal line here, let me sketch it with, show it in this. Then these points are minus 10 and 6 for us. Do you understand? We are interested in these values in between minus 10 and 6. I hope you understand the concept, and the solution therefore is that x plus 2 is less than equal to 8. Okay, let's move on to part B. Part B is like complementary of the previous one. So here what we have is x is less than 0. Let's say this is our 0, right? So, but we just not include it. So it is x is less than 0, right? And it is greater than 10. Let's say this is 10. So that is our function. So here again, what we are going to find? The midpoint. So the midpoint here is 0 plus 10 divided by 2, which is 5. And now if we have a midpoint here at 5, how much away are we from these two places? We are 5 units away, right? Do you see that? So what do we have? We need to translate our absolute function from 0 to 5. That means it becomes x minus 5, that is 5 units to the right, right? And we should be greater than this. We should be away at least 5 units away, right? So greater than 5. Do you see that? So that is our absolute function, which represents this inequality, correct? So these are the ways in which we can relate inequality, number line, and absolute functions. You could see many other examples in our folder on playlist of advanced functions, right? So these are very typical questions, and I hope now you get very good understanding of absolute function. Thank you.